An article published this week in AJR described a prospective study in which a radiology department implemented a commercial AI tool for detecting intracranial hemorrhage on head CT. Radiologists with and without AI assistance showed no significant difference in either accuracy for intracranial hemorrhage detection or turnaround time for positive reports. The authors conclude that the study failed to support use of this AI assistance tool. I'm Andy Rosenkrantz, editor-in-chief of AJR, and I'm here today to discuss the article with its senior and corresponding author, Dr. Andrew Smith, professor and chair of radiology at St. Jude Children's Research Hospital. Dr. Smith, thanks for joining us.
Oh, thanks. It's a pleasure to be here. I'm looking forward to it.
To start us off, can you give us some background about how you got involved in AI research?
Sure. Yeah, I had experience in quantitative CT research and then really made the leap to AI research after reading some articles and reflecting on the potential of AI to positively impact, our field of radiology. And from there, I just continued to read and work on team science projects, building skills in AI research, and also in clinical implementation. So that's kind of been my journey through AI.
So let's turn now to the present study. What exactly did the AI tool do?
Yeah, that's a great question. So the AI tool used in this study was a commercial FDA cleared solution for triage of intracranial hemorrhage. And so the way that kind of works is that images are routed immediately after a head CT exam anywhere in our institution. So this is a large institution, ER scanners, inpatient scanners, outpatient scanners. These get sent to like a cloud-based system. And then the AI detects the finding of intracranial hemorrhage. And then it sends a signal. In this case, we use widgets. So everyone that had a workstation, these were a neuroradiologist, an emergency radiologist, had a workstation with a widget kind of floating in the corner, and that would do the notifications to them. So it's both a detection in a way and notification specifically cleared for the notification aspects. But we thought it would be interesting to study the accuracy components as well. And we can kind of get into that. We had a lot of assumptions about how well this would work and kind of got some surprises during the study.
So with that background in mind, the study had an interesting design with two phases where AI was first run in the background, but radiologists couldn't see the results before they eventually saw the results in phase 2. Can you explain why you designed the study in that way?
Yeah, that's right. We used this study and a couple other studies too, just to study these triage systems, although I think it works for a lot of AI systems. So I think the fundamental thing was we wanted to do something prospective to get around assumptions that occur with retrospective studies. And we wanted something very practical that other people could implement and repeat at other institutions. It's very hard to repeat a randomized controlled trial. So we thought this was a good approach. So just as you said, we had the AI running in the background in phase 1, and it's not interfacing with the radiologist. So it's independently running and the radiologists are independently working. And then if you look at the results using an external reference of truth, you can kind of compare the two. So we were able to compare how well does AI compare to a radiologist in phase 1. Then we went through this training, pretty extensive training between phase 1 and 2, 3 months, everything from in-person training, videos, et cetera, to get the radiologists used to using the full AI triage notification system. And so after that 3 months of training, when everyone was comfortable with it, then we implemented phase 2, where the AI is interfacing with the radiologist. And we could go as long as we want then, because at this point, we wanted to use the system. We honestly expected it would work really well for us. That was the intent of the study, and just kind of surprised by the results of this that it didn't really work as well. And if I kind of compare that to like a randomized control trial, that would be really difficult to do. Those avoid some issues. In our study, it's possible the environment of phase 1 versus phase 2, they're temporally different in time. Maybe the staffing is different. Maybe the type of patients that show up are different. So we don't get around that bias with that design as you would in a randomized controlled trial, but it's just hard to implement. How would you blind people that this is, fake AI versus real AI or no AI versus AI, and just getting them this heightened sense of, oh, we're in a big study. I need to pay attention. So you didn't really get that with this. A lot of the radiologists didn't even know we were doing phase 1. We kind of ran it in the background. It's hard to notify everyone and get that information out. So this I think it'd just be an easier study design, a two-phase design that could be replicated at other centers, multi-institutionally. But as any study design, it has its flaws too.
And why do you think AI provided no improvement in radiologist performance?
Yeah, this is tough. I mean, there's probably several reasons. We think the first one is we sort of misunderstood our assumptions, not just about the AI, but about our own abilities. So we were thinking that, radiologists are accurate, but we didn't know that in phase one, we were 99.5% accurate. I mean, it is really tough to move the dial on 99.5% accurate. And we had almost 10,000 studies in this, but it still wasn't enough to move the dial on that. And honestly, the AI was about 93% accurate in phase one, so not as accurate as humans. Our group has 24-hour coverage, pretty fast turnaround times because of that. So we also think too, we use what we call a widget only interface. So the AI is notifying the widget, everyone has the widget, but it's not triaging our work list. And in hindsight, we thought this was a good idea. The vendor said this will work. There are reasons why clinically we didn't integrate it. It wasn't just related to our study. And so we thought that this would still work. And I think it kind of leads to this like alarm fatigue thing where it's not the only thing that's being triaged. And so we're getting this sliding thing out on, you got another finding, here's another one. How about another one? This is happening depending, and you can set filters so you don't have to see everything that's going on at your institution. But it is a little bit of an alarm fatigue. It kind of reminds me of like, a group email to get people to do something versus a targeted email to an individual. And so you're sending out this group triage message. And I don't know that everyone's super responsive to that. There's this concept of, someone else will pick that up. Maybe I'm not real sure that the widget, we're kind of blaming the widget in my opinion as something that was, a reason why this, might not work. And, again, like back on this, we really thought this was going to work. We thought this is going to work for us. We actually felt guilty and we had radiologists concerned about phase one. Why are we still doing standard care when this technology is out? And that really addresses, this is why these studies are important, where we're basically getting a negative finding in the study. We all pretty much thought this is going to work and it really didn't. So this is why it's important to do these studies, because of these assumptions that things are going to work and that sometimes they don't.
And why do you think there's been such a difference in results between retrospective and prospective AI research?
Right. Yeah. No, retrospective studies we know are flawed. They have assumptions, sometimes unrealistic assumptions. I think a big one is, for example, that if the AI is positive and it notifies you, you're going to see that and at least review the AI results, and that interface in a retrospective study, we just assume that's a perfect interface between AI and notification and human acceptance of it. But reality is different. I mean, I'll tell you, in this study and in some of the other ones, we have AI saying positive. It is really positive, not a false positive. And somehow the radiologist reads the study, misses the image finding, and also misses the notification and says it's negative. So these things can happen, and you don't really pick that up in retrospective studies. There's a lot more to that because that's not the only explanation in this one. There's team dynamics. There's how do you deal with a notification system. This was so new. This study was conducted in 2021. So it was pretty new to our institution, AI. And I can just tell you have people that don't believe in AI and don't think it's going to work. In this case, it really didn't improve in a team atmosphere, but individuals are different in how they handle it. We couldn't control for those things. I kind of like that about the study design because you may have in a population of radiologists difference in opinion in how they practice and how they use tools. So that's the point of going prospective, is you capture that information and that heterogeneity and the way people practice. Mind you, this is a single institution study, but even in that, it crossed different sections of radiologists. And, there's a lot of diversity in the way that we practice.
So you raised a really good point that the study used data from 2021. How has AI changed since then?
I mean, it's certainly possible. We saw an update occur during our study, and I'm sure there's been other updates with this. These algorithms, contrary to some belief, they are not locked. A lot of algorithms can be retrained. They may not be able to claim improvement unless they resubmit to the FDA, but if they can show internally that it works better, they can still continue that FDA process and have a live algorithm. So we know this was updated and probably has been further updated. It was 93% accurate, which is not too bad. Even if it got higher than that, I don't know that would really have had as much of an impact as some of the other things that, like the triage aspect or having work list notification might have had more impact.
So what do you think the results would be if you did a similar study today?
That's tough. I mean, I'm not sure that they would change the data by much. So even if that AI did improve, would we, and what if we had integrated with the work list? We know from some other studies that have been done that complete integration, not just integrating and leading to a flag, but actually prioritizing that work list has some effect on turnaround time. Now, that all said, we have pretty fast turnaround times. So it just depends on your environment. If there's an environment that someone's in where they don't have 24-hour coverage or they don't have a rapid turnaround time, I think you could see a more dramatic effect. I don't know, even if we got a statistically significant effect based on what we saw here, I don't know that it would be some massive improvement in turnaround time. So it might be statistically significant, but not necessarily clinically significant. And that would be hard to do. So yeah, it's really tough. What's interesting about our study is, relatively speaking, the AI failed, didn't improve our accuracy and other metrics. The turnaround times didn't improve, but with residents, when residents had a preliminary report, were reading with the staff, that actually did improve these turnaround time metrics. And so just a really interesting finding. I'm sure that's heterogeneous. I'm sure that has to do with local culture, the way that we work with our residents. There's a lot to that, but it was very interesting that we got a significant result with the residents, but not with the AI.
And with all this in mind, how are you currently using AI in your practice?
It changed things. These studies, and we did another one with pulmonary dedicated CT angiograms and a pulmonary embolism detector, or triage system, I should say, and very similar results. It did not improve turnaround time, didn't really improve accuracy metrics. So, and this just has to do with culture again. So we asked the radiologists, well, what do you want to do now? And the chest radiologists were thinking, and the ER, because lots of people read chest CTs at our institution, they turned it off. We decided to turn off that particular algorithm. Asking about the intracranial hemorrhage, people wanted to keep it on. Once it's going, even though it wasn't really shown to be effective in our system, there's more to it than that. It's a confidence builder. So I don't have direct data to do that, but we did do some surveys, and we think it has more to do with, if the AI is positive and you think it's positive, your confidence is a lot higher. And so a lot of people wanted it for the confidence. And then there's anecdotal cases. There's always going to be one where you're like, oh, I would have missed that, but the AI helped me. So, in conglomerate, doesn't make a big difference, but anecdotally, they have some cases. So ultimately, we did shut one algorithm off, kept the others on. And the other thing this taught us is, wow, you need to really know your assumptions, both about the AI, both about your institution. You probably should set some goals up front, like, okay, if this is going to do our turnaround time, what is our target? What would matter to us? 5 minutes, 10 minutes, some number that you're going to put out there and try to target and be realistic about, and then maybe test it in your own system. It's easy to do these retrospective studies. Vendors come in, they'll run it on your past data sets and show you some sort of improvement, but that's not the same thing as going forward in time and really seeing how this interfaces in a real world environment. So it taught us a lot, taught us to be a little more skeptical, to think a little harder, and not be such quick believers of what we hear from the vendors.
Those are some good lessons. To close, can you restate your study's final takeaway for our listeners?
Sure, thank you. Yeah, this is in our prospective study of nearly 10,000 non-contrast head CT exams. Radiologists without versus with AI assistance showed no significant difference in the accuracy for detecting intracranial hemorrhage or in mean report turnaround time for ICH positive exams. And the results overall fail to support use of AI assistance for intracranial hemorrhage detection on non-contrast head CT exams, at least with a widget-only approach. So we would not recommend using a widget-only approach for this kind of analysis.
Dr. Smith, thanks so much for joining us.
Thank you, Dr. Rosenkrantz. It's been a pleasure speaking with you, and our team is proud to publish this article on AJR.